Welcome to Ormat Production Tour. Electricity, the lifeblood that runs our modern world. Already back in 1965, the visionaries behind Ormat understood that power generation can and should go hand in hand along with sustainability and clean, renewable energy production. Since then, our vision hasn't changed, but we have. With 180 power plants manufactured and deployed in over 33 countries worldwide, Ormat is now the leading force in its sector and the largest geothermal power producer in the US. We are proud to enable a gross total of 3,000 megawatts production, from which 933 megawatts is produced by our own 25 global sites, fully operated by Ormat personnel. Being operators ourselves, we fully understand our clients' challenges and needs, providing a turnkey solution from geological exploration to complete operation. In this video focusing on geothermal energy, we will provide you with a thorough presentation of all the major manufacturing processes taking place on our factory premises. We will do so by exploring the integral parts of a 3D geothermal power plant model that will be used as the map for your tour. Let's start. Exploiting hot brine from a nearby production well, our first stop is Ormat's geothermal production system. Taking ownership of the majority of the power plant manufacturing processes, almost every part, big or small, is produced entirely by Ormat. In our vast machining department, advanced CNC precision machinery is shaping raw material into the desired parts, according to a controlled manufacturing plan. The main part of the production system is the geothermal production pump, which is designed, manufactured, and tested in Ormat's manufacturing facility. From the production pump, the hot brine flows through the geothermal piping system to the tubes of the heat exchanger, which includes the vaporizer, preheater, and recuperator. The heat is then transferred to the organic motive fluid, which changes its state from liquid to vapor. Ormat's heat exchangers are made of several metal types. After a sandblasting process, the exchanger plates are ready to begin their journey through our designated manufacturing hall. 4 automated submerged welding machines that weld approximately 60 kilometers submerged welding length per year, and 40 manual welders are working on one side of the hall. The plates are welded together to form the heat exchanger's outer shell. The welding quality is assured by a series of non-destructive testing procedures. Meanwhile, on the other side of the manufacturing hall, the inner tubing of the heat exchanger takes place. This bundle assembly will incorporate a vast number of 1-inch tubes. The tubes are supported using baffles and end on both sides when connected to the tube's sheet. The integration between the outer shell and the tube's bundle will occur in the middle of the manufacturing hall. Joined together, they will form the pressure vessel itself. Both the preheaters and recuperators are also being manufactured in this specific hall. The assembly of flanges, nozzle, and flat cover will finalize the making of this giant's body. Once the manufacturing is completed, the heat exchanger undergoes a series of hydrostatic pressure tests to confirm it successfully passed its endurance examination test. Depending on the client's needs, terrain conditions, and protection, the vessel is then fully painted. Installing the nameplate will conclude this piece's manufacturing process with a quality stamp. Each year, about 100 heat exchangers, a total of 6,200 tons, differing in dimensions and weight, end up here in the loading zone, waiting to be taken to the nearby port to be shipped and deployed overseas. From the heat exchanger, the organic motive fluid vapors are directed to the turbine. In the turbine, the vapors expand, thus dropping in pressure and temperature, producing rotational shaft power, which rotates the generator that produces electrical energy. The turbine's main parts are the turbine housing and outlet cone, shaft assembly, wheels, and expansion nozzles. In this hall, following shaping and machining procedures, the bigger parts of the turbine are made. Here we see the production of the turbine base, the turbine housing, and its outlet cone. Following the turbine shaft housing, each of these components undergoes thermal stress relief. The shaft assembly, which includes the turbine shaft, will be installed inside the turbine housing, which is also machined in the CNC hall. The turbine wheel will be installed on the turbine shaft. The wheel comprises the blades and blade shroud, which are all processed in this hall as well. The nozzle rings are static components that are installed within the turbine housing and function as accelerators that direct the stream of organic motive fluid towards the moving blades. The turbine nozzle rings are produced using a unique machine with specific production capabilities. In our mechanical assembly department, all parts finally come together. After ensuring that the proper safety standards were met using hydrostatic pressure tests, the turbine housing and the outlet cone will be assembled here, joined by the turbine parts that arrived from the CNC department. To install the turbine shaft and bearings inside the shaft housing, the housing will be inserted into a heating device, which will expand its steel body. After the housing has cooled and a mechanical seal is installed, it's time for a 24-hour test run on this test bench. Once the tests have been successfully completed, the shaft housing will be installed in the turbine housing. The next step is the installation of the nozzle rings and turbine wheels, which are carefully balanced after each step to make sure the operation is precise. The final steps of assembly include the sealing of the turbine with the outlet cone, the installation of the oil manifolds, and the installation of the thermal insulation cover, which reduces thermal convection and protects the turbine surface from direct contact, since the temperatures are high. The job's done. As always, our major parts are attached to the Ormat nameplate with specific details as a quality stamp. This turbine is ready to be put to work. After rotating the turbine, the motive fluid vapors flow to the air-cooled condenser, in which they are condensed back to their liquid state. The air-cooled condenser comprises several parts. A structure that functions as the base, headers through which the organic motive fluid vapors enter and leave as fluid, the tube bundle, and at the top, electrical fans which release the organic motive fluid's heat through convection. Our air cooler bundle is constructed from a large number of tubes and the bundle structure. Our finning hull is equipped with 5 separate aluminum finning lines, purposed to deliver the tubes ready for installation in the bundle. At CNC Shop, the bundle's headers are carefully drilled to ensure proper matching later on. Using a welder robot, the headers covers are welded, ready to move on down the line. Back in the bundle department, our 2 assembly lines are busy with constructing the bundle structure using the headers and beams combined. In the assembly hall, the tubes and the bundle structure meet in the middle to be integrated, forming the complete air cooler. The final construction phases include the expansion of the tubes inside the headers and the installation of the plugs. According to ASME regulations, hydrostatic pressure tests are due next, followed by the Ormat nameplate installation. Bundles are now transferred outside using the lifting machine and waiting for the final paint job to be commenced. Constant R&D is a core value at Ormat, while our engineering department is always busy with performance optimization for all of our systems. Leaving the air-cooled condenser, liquid organic motive fluid will run through the cycle pumps back to the heat exchanger where the cycle will restart. Simultaneously, the geothermal brine will be injected back into the soil to keep the geothermal reservoir balanced. We are nearing the end of our presentation. So far, you've seen all the major parts and their production phases. But what controls everything seamlessly? Ormat's electrical board assembly starts at our massive automatic warehouse, where small parts are stored and delivered upon request. After all the parts are gathered, the installation inside the cabinet frame takes place at our electrical assembly hall, where our team is busy with the precise wiring and installation of the frame inside the cabinet. All parts produced at Ormat go through rigorous quality assurance procedures, taking place in designated QA apartments equipped with the most up-to-date machinery and equipment. Although responsible for many different production phases, we pride ourselves on the fact that we have many in-house functions, from the teams and departments you've just seen, to the design, administration, project management, logistics, packing, delivery, and many more. We manufacture the equipment also to our own power plants. Therefore, we design and build it to enable easy construction on site, easy to maintain, and easy to operate. As a market leader in power generation with a proven track record of many successful projects, Ormat is up for any challenge, big or small. All setups are modular and can be tailor-made to meet our clients' needs. This concludes our tour. Thank you for joining. Ormat, powered by nature, harnessed by us.